Hello gems, welcome back to another video. First of all, wishing each one of you a Merry Christmas, and with this video we are starting with the mock test series for JEE Mains. This is something that we are going to follow in the upcoming month till you are done with your session 1. So I believe this will help you a lot for your session 1. Basically in this video we solve one mock paper in one video. Okay, yeah, that's about it. And if you are interested, you may consider subscribing. Let's get into it. Begin with question number 1, as if we were going to begin with question number 2. So two identical spheres A and B identically charged. So we have sphere A and sphere B which are identically charged. They are identical, meaning they have the same radius. They are placed at some distance, let us suppose R. Okay, so they repel each other with the force F. Okay, you can easily see that this force is by Coulomb's law, K. The product of charges, which will give us q square, inversely proportional to the square of distance between them. Okay, so that is the force F. So now we are going to bring in this picture one more sphere, one more identical sphere which is uncharged, sphere C. Okay, first we are going to place it in contact with sphere A. Okay, so here we have charge q, here sphere C, and sphere B is untouched, so the charge will remain same. Here what will happen, there will be some exchange of charge, right, because the potential is not same over here. Okay, sphere C is uncharged, sphere A is charged, right, so there will be some exchange of charge so that A and C will attain a same potential. Okay, so here basically the charge will be the average of this two. Okay, so it will be q plus 0 by 2. Since they have the same dimension, since they are identical, the charge will basically be shared. Okay, so each one of them will get a charge of q by 2 and q by 2. Okay, that's how the potential will become same for both of them. Okay, since they are identical, the maths is simple. Okay, now next we are going to bring the sphere C in contact with B. Okay, so first we brought it in contact with A, so the charge on A became q by 2, and now we are going to bring it in contact with B, okay, which has a charge q. Again you can see that the potential is not the same, right? The potential on B and C is not the same. You can work it out, kq by r, and you have to balance the potential, right? So there will be some exchange of charge until there is same potential on B and C since they are in contact. Okay, again here they are identical, so the maths is simple. You are just supposed to take the average of these two. Okay, so the charge on B is q, very carefully follow me, q plus q by 2 divided by 2. Okay, average of this two, q plus q by 2 divided by 2. So that is 1.5, 1.5 half, that is 0.75. So that is 3 by 4 we can say. Okay, 3 q by 4. So each of them will get this charge. So just like in the first case when we brought uncharged sphere and a charged sphere q in contact, they share the charge, right? Q by 2, q by 2. Here they will share this charge, 3q by 4, 3q by 4. Okay, so that will be the point where both this come in, have the same potential. Okay, so here this will get a charge of 3q by 4 and this will also get a charge of 3q by 4. Okay, now finally we are going to place the sphere C between sphere A and B exactly at the midpoint. Okay, so exactly at r by 2 from A and exactly at r by 2 from B. So here now A has a charge of q by 2. Okay, B has a charge of 3q by 4 and C also has a charge of 3q by 4. Okay, now we are supposed to tell what is the net force experienced by C. Okay, one more careful point to be remembered over here is that the force on C due to A is in this direction, right, like charges, right, so they will repel, and the force on C due to B is in this direction, again like charges, they will repel. Okay, so force on C due to B is in negative x direction. Okay, so you have to subtract these forces, right, they are in opposite direction. So F net will be, so you can clearly see that then this force will be greater, right, so we'll subtract this force, the force on B, the force on C due to B, okay, minus the force on C due to A. Okay, so here we'll get K 3 q square 3q by 4 the whole square, the product of the charges divided by the distance between them. Also remember that the distance is half now, so r by 2 the whole square, so that will be 4 in the numerator, right? So I'm just skipping the steps over here, r by 2 the whole square, so that is 2 in the denominator squared, so that is 4 in the numerator. Okay, so again we are going to follow the same steps for the force due to A. So K into product of charges, which is q by 2 into 3q by 4, okay, divided by r square and 4 again, right? So let's do it very carefully. Okay, I'll wipe this off. Hope you are able to follow. Okay, so here we have 4 will keep as it is. Okay, 4k 3q square. Okay, it will be 9q square by 16 into r square, minus here if we solve 4k, and here we'll get 3q square by, what we'll get, 4 2s are 8r square. Okay, now we can cancel some things. This will be 4s, so 9kq square by 4r square, minus here this will be 2s, so 3kq square by 2r square. Okay, and if you solve this, this will be, if you multiply 2 over here, this will be 6 and this will be 4, so same denominator. 9 minus 6 is 3, so 3kq square by 4r square. So if you see, this is what is this, 3kq square by r square. Kq square by r square is F basically, so this force, this F net, what we found is 3 by 4 of the initial force. Okay, this was the initial force, right, when A and B were placed r distance apart. Okay, so basically the new force which is experienced by C is 3 by 4 times that of the original force. Okay, so option B is the correct choice over here. Let's speed up the process. Let's move to the next question now. In this question we have a 1 meter long wire. We are going to break it into two unequal parts, x and y. Okay, so the part x, first of all we have 1 meter long wire. We are going to break it in part x and y. Okay, they are unequal in length. Okay, so x is stretched into another wire, so from x we are going to stretch it. Okay, so here first we are going to cut it, and now the x part is stretched so that we make a wire W. Now W has the length of W is twice the length of x. Okay, so basically let's assume that the length of x is L and the area of x is A. Okay, y similarly will have some unequal length, so we can say, since the wire is 1 meter long, so it will be 1 minus L, right? So if this, when you add this 2, you'll get L, you'll get 1 meter. Okay, and the area will be the same. When you cut 1 meter long wire or any wire, basically the area does not change, right? You may change its length. Okay, the two wires may have different lengths or may not, but the area won't change, right? So when you cut it, the area won't change, but when you stretch it, the area will change. Okay, so here for wire W, okay, this is for wire W, we are going to stretch it 2 times the original length, right? From x, which has length L, okay, we are going to make the length 2L, right? The length of W is twice the length of x, so length of W is 2 times of L, right? 2 times the length of x. Okay, so in doing so, what we are doing, the area will be decreased. Okay, so basically when you stretch something, the area will, the cross section basically will become thinner, right? You can imagine it. So if I have a wire like this wide, okay, so when you stretch it to twice of its length, the area of cross section will reduce, right? It reduces such that the ratio A into L is constant. Basically the volume should be constant. So if you stretch the wire twice its length, the area will become half. Okay, so if you stretch the wire twice its length, the area will become half, so that this ratio remains the same. Okay, so if you see W was stretched piece of x. Here if you see A into L, what is the volume? A into L. Here if you see again A by 2 into 2L, the 2 will get cancelled, again you have AL, right? So basically you're supposed to keep this constant, or you can use the formula A1 L1 is equal to A2 L2, or basically you can see that the length has doubled, so the area will become half. Okay, so here we have reached, we have wire W. Now we are told that the resistance of wire W is twice the resistance of Y. Okay, so first of all, what will be the resistance of Y? Okay, so first of all, let us find the resistance of X. Resistance of X will be rho L by A, right? If you know the length and the area. Here rho is same for all of them since it's one wire, same material, right? And here the resistance of W will be, if you see, it will be, I think, rho 2L by A by 2, right? I'm substituting the particular areas and basically the length. Okay, so here you'll get this 2 will go in the numerator, so you'll get rho L by A times 4, right? So 4, this is rho L by A is nothing but resistance of X, so 4 times the resistance of X. So basically the resistance of W is 4 times the resistance of X. Okay, so basically when you solve this, you get the resistance of W as 4 times the resistance of X, and in the question we are told that the resistance of W is twice the resistance of Y. So resistance, also we can write resistance of W is twice the resistance of Y. So you can basically compare these two equations to find a relationship between the resistance of X and Y. Okay, so resistance of X, so we can basically equate these two, right? This is also resistance of W, resistance of W. So 4 times resistance of X equals 2 times resistance of Y. Okay, so Rx by Ry will be 1 by 4 or 1 by 2, right? So 2 by 4 or 1 by 2. Okay, so basically the ratio of their resistances will be 1 by 2, but we are supposed to find the ratio of their lengths, which will be also same, because basically if you see, resistance is directly proportional to length, right, when the area is constant. Okay, and in this case the area for Y and area for X is same. Okay, because they are cut pieces. Okay, we are not stretching them. X and Y are cut pieces. Okay, so the area for both of them is same, so resistance is directly proportional to length, so the ratio of resistance will be the same as ratio of length. That simple. Okay, so 1:2 is the correct choice over here. Over to the next question. Number 3 and 4 over here. In question 3 we have an unpolarized beam of intensity 2 I naught, okay, which is passing through a Polaroid P. Okay, so after passing through P, it will have an intensity I naught, right? So whenever an unpolarized beam passes through a Polaroid, its intensity becomes half. Okay, so its intensity will become half. Okay, so don't confuse this with Malus law. Malus law is only when we have two polarites, right? So next we'll apply the Malus law. So whenever an unpolarized beam passes through a Polaroid, the intensity becomes half. Okay, that is the rule of the thumb, if you will remember. Okay, now we have a Polaroid Q. So here is where you'll use Malus law, which has its pass axis at angle 30 degree with relative to P. Okay, so its pass axis is making an angle 30 degree relative to P. So you are supposed to find the intensity over here. Okay, I. So I over here will be given as the intensity which is going inside this Polaroid. Okay, which is I naught, then cos square phi. Okay, I naught, the intensity which is going in the Polaroid, and cos square phi. Phi is the angle that the pass axis is making, which is relative to the first Polaroid. Okay, so this is I naught, and cos square of 30, cos 30 is root 3 by 4, right? So cos 30 is root 3 by 2, and that squared is 3 by 4. So 3 I naught by 4, which is option C. Okay, quite straightforward question. Let's come to this one. We have here alpha particle and a proton, which are accelerated by the same potential. Okay, sorry, you are supposed to find the ratio of the linear momentum acquired. Okay, so basically we'll find the kinetic energy. Okay, so half of each of these particles, so half m alpha v alpha square. This is the kinetic energy of the alpha particle. Okay, so here it will be equal to charge on the alpha particle times v, right? So basically when you accelerate a particle using potential V, you can write the kinetic energy equal to the, this is basically the work done, Q into P, right? So kinetic energy is equal to the work done. Okay, so this is for alpha particle. Similarly, we can write it for proton. Okay, Q of proton, and potential is same, V. Okay, so we are supposed to find the ratio of their linear momenta. So first of all, let us take the ratio of this. This will give us an idea about V. Okay, so let's do it. Okay, so here you'll get, when you take the ratio, so m alpha by V alpha. Okay, and here you will get m of proton, V of proton, here this is squared, and here V and V will get cancelled, so Q of alpha upon Q of proton. Now we know that alpha particle has twice the charge, basically helium nucleus, so twice the charge of proton and 4 times the mass, right? So if the proton has mass, so for proton, suppose the mass is m and the charge is q, then for alpha particle the mass will be 4m, 4 times the mass, 2 times the charge. Okay, so for alpha particle the mass will be 4 times the mass of proton, so basically you can write it is 4, right? So this ratio will be mass of alpha particles is 4 times the, okay, I'll write that, 4 times the mass of proton upon mass of proton, and here V alpha will be that will find the ratio of the velocities, V of proton square. Here what we'll get, the charge on the alpha particle, which is 2 times the charge on the proton, so this and this will cancel, this and this will get cancelled, and we'll get V alpha by Vp as 1 by 2 and under root, right? So 1 by root 2. Okay, so that is what we get, V alpha by Vp, this ratio. But we are supposed to find the ratio of linear momenta, which is also very simple, P alpha by P of proton. Okay, again you are given the alpha particle first and proton later, so it is P alpha by P proton. Important point to remember, so that will be m alpha V alpha upon m of proton divided by V of proton. So we already know that this ratio is 4, right? The mass of the alpha particle is 4 times the mass of proton, here you can see, and this ratio we have found it out to be 1 by root 2. So when you simplify this, 4 is nothing but 2 into 2, and 2, the other 2 you can write it as root 2 times root 2. Okay, so 1 root 2 will get cancelled, and you'll get 2 root 2 is to 1, 2 root 2 is to 1, right? So I think option B is correct over here. So that's about question 4. Over to the next question. 5 and 6 over here. In question 5 we are given 5 statements. Among this only 2 are correct. So we are supposed to select that options which has both the correct statements. Okay, so the first statement reads, volume of the nucleus is directly proportional to the mass number. Okay, you can first of all recall the relation that R is R naught a to the power 1 by 3. A is the mass number over here, right? This is the relation for the radius of the nuclei, right? So if you cube it, okay, because basically your volume is 4 upon 3 pi r cube, okay, it's proportional to the radius cube, right? So for a sphere, so here if you cube it, we'll get r naught cube, which is of course a constant, and here if you cube it, this is cube root, so the cube root will go, right? So you can see that volume is directly proportional to the mass number. Okay, so A is definitely correct. Okay, so you can see A in each option, right? So almost in every option. So this can be correct. This can never be correct. Okay, I'll leave physics if that is correct. Okay, so option A is correct. Let's see which other statement is correct. Volume of nucleus is independent of mass number. Of course, volume is dependent and it's directly proportional. So this cannot be correct. Okay, so then density of nucleus is proportional to mass number. Now in your NCERT it is told to you as a fact that density of nucleus is constant. Okay, any density of any nuclei is constant. It's about 2 or 3 something into 10 to the power 17 kg per meter cube, right? Yeah, your nucleus is so much dense. Okay, so yeah, so your the density basically of the nuclei, any nuclei, is constant and it does not depend on the mass number. So here we are told it is proportional to mass number, no. The proportional to the cube root, no. okay, the density of the nuclei is independent of the mass number. This is statement E. So statement A is correct through this, and statement E is a fact. Okay, so density of a nucleus is independent of mass number. Option B, A and E. A and E, those two are correct. Okay, of course there is a proof for this, small proof, you might find it in a reference book, but I'll recommend that you remember this as a fact, that density of a nucleus is independent of the mass number. It does not depend. Okay, it's a fixed value for every other or every nuclei that is there. Okay, so coming to question number 6, we have an object of mass 1 kg which is taken to a height from the surface of the earth. Okay, so it is taken to a height from the surface 3 times the radius of the earth. So suppose the radius of earth is r, then it is taken to a height from the surface, mind you. Okay, so even if it's not mentioned, heights are always measured from the surface, so that is something to keep in your head. Okay, so whenever they mention height, especially in questions of gravitation, you are supposed to measure it from the surface. Okay, so it's 3r from the surface, not from the center. Okay, now so it's taken to this height. Okay, it's 1 kg object. Then you are supposed to tell what is the gain in the potential energy. So initially it is placed on the earth, and now it is taken to a height 3 times the radius of the earth. So what is the change in the potential energy? Of course this distance will be nothing but r, right? So this is r. So if you can see that it is taken to a distance of 4r from the center of the earth, right? So initial potential energy will be gmm by r square. So g capital M small m, the mass of the object, divided by, it's actually negative, so I'll write that. So minus g capital M mass of earth, small m mass of the object, divided by, initially it is on earth, right? So initially the object was placed over here at a distance r from the center. Okay, so we'll consider this as the reference line. Okay, so we'll measure this distances from here. Okay, here we'll assume that potential energy is 0. Okay, so here the potential energy is this. Okay, gmm by distance is r. Okay, final potential energy, what will be that? That will be gmm minus g capital M small m. Okay, nothing of this has changed, only the height is changed. Height is 3r, no 4r. Okay, we are measuring it from the center. Okay, so this is the height. Okay, so basically you are supposed to find the gain, the change in the potential energy, final minus initial. So u final minus u initial, you have this is 1/4, right? So 1/4 and this is 1. So basically it's 1 minus 1/4. Okay, this is 4r and this is minus 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 minus, so that will become plus gmm by r, right? So 1 minus 1/4 is 3/4. So 3g capital M small m by r. Okay, now you can use this relation. You are given the value of g and r, so you can use the relation gm is equal to g r square. So let us use that relation. U is equal to we can substitute in place of gm as gr square, so 3gr square into m divided by 4, right? So here we'll have 3g is 10, r 1r can get cancelled with this in the bottom, so we have 6400 and into 10 to the power 3 because it is in kilometer. Okay, so and in the denominator we have 4, so 4, this is 16 za, so 1600, and 16 3 za is 48, right? So we have 48 and how many zeros? So 1 2 3 and more 3, right? So that is total number of 6 zeros. Now 6 zeros is referred to as mega. Okay, so this is in joules, so 10 to the power 6 joules is megajoules, so 48 megajoules, or you can remember it as million. Okay, basically a million has 6 zeros. Okay, so whenever you say 1 million subscribers or 1 million is basically 10 to the power 6. Okay, so that is that m. In physics we call it mega, right? So 48 megajoules or 48 million joules as you might call it. Okay, so that's our answer. Over to the next question. 7 and 8 over here. In question 7, long story short, we are given this system. Okay, we are told the values of m1 and m2. We are told that the system is ideal, the string is massless, the pulley is frictionless, the inclined plane is smooth, so on and so forth, and that the system is at rest, which means that the system is in equilibrium. Okay, all the forces are balanced. Okay, nothing, no blocks are moving, neither the inclined plane is moving. Okay, you are supposed to tell what is the force on M1, force on this block due to the inclined plane. Of course, there is the contact between these two, so you can see that the block itself will put a force, its weight, a component of its weight on the inclined plane, and there will be an equal and opposite reaction force from the inclined plane. Okay, and let's draw the FBD, and it will be quite clear from it. So first of all, there is tension T in the string. Here also there will be tension T, right? So this tension is balanced by the weight. So this tension arises due to the weight of this block M2G. Okay, so this is the weight and it is balanced by the tension. The same tension comes over here since the string is massless. Okay, and this force, this tension T for this block is balanced by m1g sine theta, right? Along the incline, remember that it is sine theta of the weight. Okay, m1g is the weight and sine theta of weight along the incline. Perpendicular to the incline, it will be cos theta, m1g cos theta. So along the incline, it is sine theta, perpendicular to the incline, cos theta. Okay, you can directly remember that. So basically, you are supposed to find r, right? R will be nothing but equal to m1g cos theta, because the system is in equilibrium. Okay, and of course the r is the reaction force from the incline. So yeah, so both of them will be equal. Okay, and here in this case we can also write other equations as this and this force will be equal, right? Since the block m1 is not moving, this force equals this force equals this force. Okay, so T equals m1g sine theta, and here from here we can write T is equal to m2g. Okay, so from both these equations, I'll borrow space from there. So from both this equation, you can write that m1g sine theta equals m2g. Okay, why are we doing this? Because we want to find sine theta. Okay, so from sine theta we can find cos theta, substitute over here and get the answer for r. Okay, which is what we want. Okay, so m1 has 5 value, gg you can cancel, sine theta, and m2 is 3, so sine theta is 3 by 5. Okay, and if you can remember, this is the famous 37-degree triangle. Okay, so if we have theta over here, this is 3 and sine theta will be 3 by 5, right? So 3 in the opposite and 5 as the hypotenuse. So this will be 4, 3, 4, 5, right? You can use Pythagoras triplet, or you can also use Pythagoras theorem to find this side. It will be 4. Okay, so now you know that cos theta will be, cos of this angle will be 4 by 5, right? So now you know cos theta, you can easily substitute in that r and find the reaction force, the force on the block due to the inclined plane. m1g is 5, okay, g is 10, and we have cos theta as 4 by 5. Okay, 4 by 5, 5 gets cancelled, 4 tens are 40, right? So option B, 40 newtons is the correct choice over here. Let's come to this one. This is also a straightforward one, okay, unless you get tricked by it. Okay, so here we have the momentum of the body is increased by 20%. You are supposed to tell what will be the increase in the kinetic energy. You might be tempted to use this relation that energy is p square by 2m, the relation between your kinetic energy and momentum. Kinetic energy is p square by 2m. So basically the change, the increase in the kinetic energy is delta 2 times delta p by p, right? So here you can directly see that the momentum is increased, so percentage on both the sides. So momentum is increased by 20%, so 2 times that, which is 40%, and you might say 40% is the correct answer, which is not. Okay, so this formula, this is only true for errors. Okay, errors are very small, right? They are 1%, 2%, maybe maximum 10%. Okay, so you can use this logic only for maybe errors up to 10%. Okay, so this question you are supposed to follow the conventional method. What is the conventional method? So first of all, we are told that the momentum is increased by 20%. So suppose initial momentum is p, so final momentum will be this p plus 20%, right? So 20% of this will be 0.2, right? 20% is 20 divided by 100 times of p, right? 20% of the initial momentum, so which is 0.2 of p. Okay, so this will be 1.2 p. This is 1 p and this is 0.2, so 1.2 p, right? So now the energy and the initial energy we can say associated with this momentum is p square by 2m, and final energy will be nothing but p final square by 2m, which is of course different, which is 1.2 p the whole square by 2m, which will give you 1.44 p square by 2m. Okay, now how to find the change? The change in the energy, this is the conventional method to find the increase. It is basically sorry, final minus initial upon initial into 100%. Okay, so final is this, excuse me, and you can see that just excuse me for a minute. Some coughs later, let's get back at it. So initial is, sorry, final minus initial, so final is this. I'll basically take p square by 2m common. It is also there in the denominator, so basically it will get cancelled, right? So p square by 2m in the numerator, so this minus the initial momentum, this, so p square by 2m is common. Okay, so it is 1.44 minus 1 over here, right? So that is here we have p square by 2m, and here also in the denominator p square by 2m, which will get cancelled. Okay, and that into 100%, right? So this is 0.44 and into 100, that will be 44%. Okay, so the answer is not 40, it's 44. Okay, so yeah, 44, option C is correct. Let's move to the next question now. And 10 over here. So in question 9 we are told that the torque of a force this about the origin is tau. It acts on the particle whose position vector is this. Okay, you are supposed to find tau. Tau is nothing but the torque. The torque is given as r cross f. So it's a pretty straightforward question. How will you define r cross f? It is basically ijk when you are given the component form. So it will be ijk, the position vector r, and then f. Okay, r and then f. Order is important, so r and then f, although f is given earlier. Okay, that is to confuse you. So r first, 2, 2 and 1, and then we have 5, 3 and minus 7. 5, 3 and minus 7. Okay, so let's solve this. So I cap and cut this off, minus 14, minus 14, minus 3, minus 17. Okay, so directly if you see, only this option is correct, minus 17. Here we have positive 17. So again, if you want to do it for tasalli, we can do it. So j cap, this is minus 14, and minus 5, minus 19, right? So this will become plus 19. Okay, and plus k cap, here cross this out, 6 and 6 and minus 10, minus 4, yes. Okay, so C is the correct choice over here. Pretty straightforward question, right? So here we have in question 10, light which is entering from air. Air is rarer medium to a denser medium. Okay, so it first of all makes an angle 45 degree at the interface. Okay, it's unclear whether it makes the angle with the interface or with the normal, but the angle is 45, so 45 here or 45 here is the same, right? Basically the sum is 90, right? So otherwise if the angle was 30 degrees, then it would have been a debate, but the angle is 45, so if you take 45 over here, again the angle with the normal will be also 45. Okay, 45 plus 45 is 90. Okay, so anyways, so there is refraction happening, of course. So the ray gets refracted towards the normal, right? Rarer to denser, so towards the normal, and it is deflected by an angle of, deviated by an angle of 30 degrees, right? Deviated by an angle of 15 degrees. I hope that is correct. Okay, so that is deviated by an angle of 15 degrees. So basically what will be this angle? This angle will be nothing but, so if you see, this is also 45 and this should be, this total should be 45. This is 15, then this should be 30, right? So basically this small angle is 45 minus 15, right? 45 minus 15, or you can see that this plus this this total angle should add up to 45. So if this deviation is 15, this should be 30. Okay, so the angle that the refracted ray is making with the normal, the angle of refraction basically is 30 degrees. Okay, so that's all the data that we needed. Here we are supposed to find the refractive index of the denser medium. So we just use the Snell's law. So mu1 sine theta 1 is equal to mu2 sine theta 2. Okay, I write it in this form. Basically it's easier to remember instead of writing the refractive index as the ratio of sine of theta 1 and theta 2. Okay, I write it in this format. Okay, so medium 1 is air, so air refractive index will take it as 1. Theta 1 angle of incidence sine 45. Okay, then mu2 we are supposed to find, and sine of theta 2 sine of angle of refraction, not 15 degrees, it will be 30 degrees, right? Angle of refraction is angle refracted ray mixed with the normal, right? So sine of 30, sine 30 half, so mu2 into half, and here we'll have sine 45 as 1 by root 2. So this will come to the other side, so it's 2 by root 2. So mu2 is nothing but 2 by root 2 is root 2, right? 2 by root 2 is root 2. Root 2 is nothing but 1.44, right? It's close to 1.44. Basically 14 square is 196, right? So something around 1.4. So basically root 2 will give you 2. Okay, don't worry about that, directly remember the value. Root 2 is 1.44, right? This is something 4 by 3. It's the refractive index of water. This is root 3, 1.732, and that is something random. Okay, so over to the next question. 11 and 12 over here. In question 11, we are supposed to express in terms of resistance R and time T the dimensional formula for mu by epsilon naught. Mu is permeability and epsilon is permittivity. Okay, now there is no easy way of doing this. Of course, it's doable, but it's lengthy. Okay, I don't know any easy way of doing it. If you know, do let me know in the comment section. Okay, I'll do it the hard way. But of course, don't tell me that you by heart the formula, the dimension formula of this, and then just substitute. That's easy, bro. No, don't tell me that. If you have any other different way of doing it, do let me know. Okay, which makes it way simpler. Okay, here I'm going to do it the hard way. I'm going to find the dimensional formula for resistance, mu and epsilon naught, and then express one in terms of other, the ratio in terms of that. Okay. So let's begin with resistance. For resistance, we'll use V is equal to IR. So R is equal to V by I. So basically, if you see V by I, so V is potential. Potential is work per unit charge. So work is just like potential energy, mL2 T raised to minus 2. So basically, I'm substituting, and charge is Q is IT, right? So charge is current times time. Okay, and here in the denominator, this is V, right? Work by charge, and this is I. I is again ampere. Okay, so here we will have ml square. Okay, that is unaffected. A square in the denominator, that will go on top. Here we'll have t to the power minus 3, fine, and this is a square in the numerator, power minus 2. Okay, now the next thing, we will find the dimensional formula for mu. First let us find the dimensional formula for epsilon. Okay, because that is easy. I believe that is easy. So that will be F is equal to K Q square, or I shall write it as 1 upon 4 pi epsilon naught Q square by R square, right? So this will be epsilon naught, the dimensions of it will be 1 upon 4 pi. We can just ignore that, that is constant. Okay, epsilon naught goes over here. Q square is A into T the whole square. Q is A into T, right? Q is IT or AT, and divided by F will come down, F R square. So R square is length square, and F is ml T raised to minus 2. Yep. So what do we get? We get epsilon as, okay, so this is for R, right? This is for R. Okay, we'll save it, and we get epsilon as what do we get it as? M minus 1 L cube, this is L cube, no L in the numerator, so L to the power minus 3, T to the power minus 2, and that will go on top as plus 2 and plus 2 and plus 2, yeah, plus 4. And we also have a square, right, a square. So this is the one that we get for epsilon. Now for mu, it's a bit complicated. We have to start with, you just cannot start with your Biot-Savart's law, B is equal to mu upon 4 pi ideal sin theta upon r square, because you won't know the dimensional formula of B, okay, magnetic field. Don't tell me you know that. Wow, you can use that then. Okay, so I don't know, so I'll that's why I'm doing it the hard way. I don't know the dimensional formula of many of this. You as a JEE aspirant might know it, okay, you might know it better, so that might make this question easier for you. Okay, it's easy but it's lengthy. Anyways, let's come back. Okay, so what I'll begin by finding the dimensional formula for B, magnetic field. Okay, so that will be, I'll use the formula F is equal to QVB, Lorentz force. Okay, so I'm just ignoring the sin theta, so B will be F by QV, right? So dimensional formula of B is F by QV. F is mLt raised to minus 2, mass into acceleration. Q is AT as we know, and V is LT to the power minus 1, mass meters per second, right? So this gives us, what does this give us? This gives us L and L will get cancelled out, and this will be T to the power minus 1 only, right? So 1 will cancel, yes. Okay, so M T to the power minus 1, L is 0, T to the power minus 1, okay, I hope I'm correct. Then A to the power minus 1, okay, this and this will get cancelled, so let's not worry about that. So T to the power minus 2 and A to the power minus 1, okay, I hope I'm correct. Okay, so this is for magnetic field. We are not done yet, we are supposed to find for mu. For mu, actually we can use mu 0 I upon 2r. This is for loop, right? This is the magnetic field at the center of the loop, circular loop, yeah. So we can use this and find the dimensional formula for mu. Mu will be basically B times 2r. B is this, m t raised to minus 2, a raised to minus 1 into r is length, basically radius, right? Radius of the ring. And what do we have? What do we have? Upon I, right? Upon I. So I is a, of course. So this is m t to the power minus 2, a to the power, so L, I'll also slide that in. So m L t to the power minus 2, a to the power minus 2. I hope you were following this the whole time. I'm not taking a nap. So this is the formula for mu. Okay, so we have the formula for mu. We have the formula for epsilon. Let's take the ratio. So m, where is that? Okay, we have to take this by this. Okay, this by this. So you can see that it will become m square. Okay, so if we take mu by epsilon, let's take it term by term. So m minus 1. So this divided by this. So that will become m square. Right, this divided by this will go on top as plus 1. So now L divided by L to the power minus 3, so that will go on top as plus 3 plus 1 plus 4. Wow. Then we have this t to the power minus 2, and in the denominator t to the power minus 4, so that is I think that will become minus 6. Okay, minus 6. Okay, then finally if you see a to the power minus 2 and a to the power 2 in the denominator, that will become minus 2. So a to the power minus 4. Okay, you can easily see that this is nothing but the square of this, right? M square L to the power 4. Okay, then this is 6 and this is 4, right? So basically this ratio is corresponds nothing to but resistance square. Okay, it's in terms of resistance. Okay, it's r square. Okay, sorry. So that's our answer. Let's move to this one. Okay, here we are given the acceleration velocity graph, and we are supposed to tell the slope of velocity displacement graph. We are supposed to tell dv by dx. Okay, this is the slope of velocity displacement graph. Just a moment. So we are supposed to find this. Okay, actually it's very simple. You can see the nature of the graph is linear. So basically the equation of this will be a is equal to some k times or m in the usual notation times v, right? I will not write m because you might confuse with mass. So I'll write k times v. Basically this is a straight line, right, passing through the origin. So you can remember the equation y is equal to mx plus c, right? Here c is 0, the x-intercept is 0, so this is 0. So basically it's a line of slope m but 0 intercept. So y is equal to mx passing through the origin. Okay, so y is equal to, so a is equal to some constant times v. That constant is the slope. So y is equal to the slope times x. So y is equal to a is equal to slope times, which is k, times v. Okay, so that is the equation between a and v. Okay, now one more fascinating thing about acceleration, you can express it as v dv by dx. Okay, I hope you know this. Okay, you can easily write it as, I'll show you how. So if you write a as dv by dt, okay, right, acceleration is rate of change of velocity. You can write, you can divide dx, divide and multiply dx. So dx by dt, this term is nothing but v. So v, and we have dv by dx, right? So you can write basically a as v dv by dx. Okay, you should remember this. This is a very common result. Okay, and yeah, it's I will recommend you to remember that. Okay, so we'll write a as v dv by dx, and here we have kv. V will get cancelled. This is nothing but the slope of your velocity displacement graph dv by dx, which we are supposed to find. It is nothing but equal to k, the slope of line, which is constant. Okay, it is not linearly increasing or decreasing, it is constant. Okay, k is a constant over here. The slope of this line is constant, right? This, suppose this angle is theta, then slope will be tan theta, right? Some constant value for a line, right? So the slope is constant, so the slope of the velocity displacement graph will be constant. Okay, so that's our answer. Let's move to the next question. 13 and 14 over here. In question 13, we are going to bend a wire of length L into a circle. Okay, and it is carrying a current I. We are supposed to tell what is the magnetic moment of this circle, okay, of this loop. It's very simple. M equals IA. This is the formula for magnetic moment. So area of the circle is pi r square. Okay, and r, you can find r if you see the answer is in terms of length. So here you have seen that this length itself is bent into a circle, which means that the length of this wire is nothing but the circumference of the circle, right? The length is bent into a circle, so the circumference will be equal to this length, right? So from here you can find r will be L by 2 pi, right? So substitute it over here. I pi, in place of r you put L by 2 pi, and that's squared. Okay, so let's just directly square it. L by 4 pi square. Okay, pi and pi will get cancelled. I L square by 4 pi, which is option A, I guess. Okay, so now question number 14. A monkey of mass 4 kg climbs a massless rope. So the maximum tension that your rope can handle is 500 newtons. You are supposed to tell what is the case where, among the following, where the rope will break. Okay, so let's not be monkeys. It's very simple. Okay, the maximum force the rope is going to experience is when the monkey is climbing the rope, right? And it's JEE, so only one option will be correct. Okay, so the maximum force will be experienced when the monkey is climbing up the rope. Okay, just like a lift, because when the monkey is climbing up, he's pulling down the rope, his weight is also down, so mg plus ma. Okay, just like the lift. Okay, when it's going up, it's mg plus ma, right? And it's when it's going down, it's mg minus m. Same case. Okay, so I said when it's going up, the force is maximum. okay, going up with certain acceleration, the force on the rope will be maximum. And if you see only one case, the monkey is going up, and that should be correct, okay, because in that case it will be mg plus ma, and that value will be greater than 500 newtons. Don't believe me? Let's do it, okay, because when it's climbing down, it will be certainly mg minus something, right? And only one option should be correct, and among this, the one with the maximum value will be correct, right? But anyways, if you want to avoid the smart work and do it exactly, so let's study it for the case when the monkey is just hanging over there, okay? Monkey is hanging over there. So basically in this case, T should be equal to mg, right? So let's see if the rope can support the monkey hanging on the rope, okay? So T can support mg or not. Let us see that, okay? So what will be mg? Mg will be mass is 4 to gravity is 10, acceleration due to gravity, so 40 newtons, right? 4 kg into I think this should be 40 kg, okay? Yes, it should be 40 kg. Monkeys cannot be so light. I know you. I'm sorry, 400 Newton. Then we have, so if you see this mg is less than tension, right? This is less than the maximum tension that the rope can handle. So of course the rope will be able to handle this. But what about the time when the monkey is climbing, okay? When the monkey is climbing, the tension will be mg plus ma, as I said, right? He's also pulling the rope down, and his weight is also acting in the downward direction. So mg plus ma, okay? So mg, m is 40, we can directly take m common, g is 10, and a, let's take this example, 5. So this is 40 into 15. 15 fours are 60 and 1 was 0, 600 newtons. You can see that easily this is greater than the maximum force, right? This tension is greater than the maximum allowed value. In this case, the rope will break. If you see for the other cases, it will be mg minus a, okay? And in this case, it's basically acceleration is 0. It is constant velocity, okay? So basically a case like this, the rope can handle this. The rope can handle this because this is g minus a. This value will be obviously less than mg, right? It will be less than mg minus ma, mg minus something, okay? So it will be less than mg, so of course less than this, yep. And monkey falls freely, basically 0 force, right? He'll just leave the rope, okay? So no string attached over here, no puns intended over there, but over to the next question. Question number 15 and 16 over here. In question 15, we are supposed to find the equivalent resistance between A and B. Now, it might seem complex, but it's actually very simple. So let's begin at A. Okay, so as we go from here to here, if you see at this point, the potential will be also A. Suppose the potential at this point is A, so the potential over here will be also A. There is no resistor, inductor, or any circuit element across which potential can drop. So if potential over here is A, here also it is A. Now what about the other points? Okay, no other points, no other junction. Here there is one junction, okay, and yeah, it's coming through a resistor. So let us call that to be some potential C. Okay, so of course when you start from B and go from here to here, there is a resistor, so there will be some potential drop, and that will be some different value, right? Here it is B, here it is C, okay? Now let us draw A, B and C, okay? And remember that we are supposed to find equivalent resistance across A and B. So A and B will be the endpoints, A and B, and C will be somewhere in between them, okay? So if we consider this resistor, okay, let's consider one by one the resistors. Okay, so let us consider that one first. So you can see that it is between, this point will also have potential B, right? No circuit element over here, so here also the potential is B. So you can see that this resistor is between A and B, fine. Okay, so this is R. Now let us consider this one. This one, if you see, this one and this one, these are in series, right? These are in series and they are between A and C. So two resistors in series between A and C. So R and R in series between A and C. Now what about this resistor? This resistor is also in series, between A and C, but it's parallel to this connection, right? So it's also between A and C, but it is parallel to the other two resistors between A and C. Okay, so it's parallel to this. Okay, now the only resistor remaining is this one, right? So it is between C and B, right? So it's over here. Okay, now the circuit is very simple. We can easily find the equivalent resistance of this. So this is 2R, right? R and R, 2R and R in parallel. We directly know this. Those who have been following this is 2R by 3. Okay, whenever you see 2R and R in parallel, the answer is 2R by 3, R big by 3. Okay, so 2R by 3. So we have 2R by 3 over here. Okay, and then we have R. Okay, and here also we have R. Okay, now simplify this, 2R and that is I think 5R by 3 and R in parallel. So equivalent will be given by this. Okay, 5R by 3 and R in parallel, that is the resistance between A and B. Okay, so that will be product upon sum, right? So 5R by 3 into R divided by 5R by 3 plus R. Okay, so this will be 5R by 3 plus R, that is 8R by 3. Okay, this 3 and 3 can get cancelled, this and this can get cancelled, so that will become 5R by 8, which is option B. Okay, that's correct. Let's come to the 16th one. Again, I think very straightforward. And can be easily doable. Here you see the triangle of 3, 4, 5. So answer I guess is 6, 8, 10. Okay, so I think 10 times that. Okay, 10 times 10 to the power minus 5. So I think this should be the answer. Let's do it. Okay, so let's actually try and solve it. Okay, so we are given that the vertical component of Earth's magnetic field is 6 into 10 to the power minus 5 Tesla. And angle of dip is given as 37 degree. We are also told that 10 of 37 is that. So we are supposed to find the resultant field. Okay, so first of all, angle of dip, 10 of the angle of dip is given as BV by BH. Okay, so from here you can find the horizontal field. So from once you have the vertical and the horizontal field, you can easily find the resultant field. The resultant field will be nothing but by Pythagoras, right? BV square by BH square. Okay, so 10 of 37, here you can directly write it as 3 by 4, and BV is 6 into 10 to the power minus 5, and BH you can find from here. So BH will be, so this and this can cancel, 2 and 8 into 10 to the power minus 5 Tesla. Okay, so if you see this is the famous triangle 6, 8, 10. So this will be 6, this is 8, so the answer will be 10. And you also have the power of 10 to the power minus 5, so this will be your answer. Okay, so I'm basically using Pythagoras triplet, so 10 to the power minus 4 Tesla. You can substitute these values, you will get the same answer. So that's your answer. Over to the next question. Question 17 and 18 over here. In question 17 we have a capacitor which is as shown. Okay, each plate has area A, the D1 amount, the D1 length of this capacitor is filled with a medium of permittivity epsilon 1, and D2 amount is filled, D2 length is filled with another dielectric medium of permittivity epsilon 2. Okay, you are supposed to find the equivalent capacitance. Okay, it's actually very simple. You can simply redraw the system as two capacitors of first of length D1, okay, which has this medium of permittivity with epsilon 1, and with that another capacitor in series of length D2. So this system can be simplified as shown. Okay, so instead of treating it as one capacitor, you can treat them as two capacitors placed in series. Okay, you just split like that. Okay, so now you have two simple capacitors placed in series. C1 is the capacitance of this. It will be simply A epsilon 1 by D1, right? So A epsilon naught by D. Okay, So here the medium is having permittivity epsilon 1, so that follows. Okay, and here for capacitor 2 it's A epsilon 2 by d2, the length. Okay, so now these two are in series, this C1 and C2 are in series. So how do you find equivalent in series? Basically it is product upon sum, right? So C1 C2 upon C1 plus C2, this is for capacitor. Okay, in series you take the product upon sum, right? So A epsilon 1 by d1 into A epsilon 2 by d2 upon their sum A epsilon 1 by d1, I can take A common, plus A epsilon 2 by d2. Okay, so one A can get cancelled and we'll have what will we have? So we'll have A epsilon 1 epsilon 2 upon d1 d2, and if we simplify this, okay, if we simplify this will be epsilon 1 d2. Okay, so I'll directly write epsilon 1 d2 and epsilon 2 d1, that will come in the denominator, epsilon 1 d2 plus epsilon 2 d1, and this will flip over on the top, d1 d2. Okay, those who didn't get it can solve it step by step. So this is what we get: A epsilon 1 epsilon 2 epsilon 1 d2 epsilon 2 d1. I think it's option A. Okay, epsilon is not there in the picture. No, I think this is the correct one. Okay, so option A is correct. Okay, question 18 is very simple. You can actually do it closing your eyes, just like that. Okay, actually that's wrong. Okay, editor, edit that. You can actually do that closing your eyes. That's correct. Yes. So how do we do that? Because you can clearly see that we are supposed to find the current in the circuit, and this diode, if you see, it's reverse bias, right? So no current will flow over here. Okay, this branch is as good as nothing. Okay, it's like an open circuit. Okay, so this diode is reverse bias. Okay, so the simple circuit that we have is this one: 12 volts battery, 4 ohm resistor, and then we have this resistor of 2 ohms. Okay, this diode will conduct it. We are supposed to consider it as ideal diode, zero resistance, and we have a 12 volt battery. Now that is a very simple circuit. I will be simply given as V by R. V is 12, R is equivalent resistance. If you see, both of them are in series, right? Same current will flow through them, so both of them are in series. 4 plus 2 6, and this will be 2 amperes. So yeah, you could have done it closing your eyes. Exactly. So yeah, that's the correct answer over here. Let's move to the next question. So question 19 and 20 over here. So here we are given a logic gate configuration. This is a OR gate, NAND gate and AND gate. Okay, we are supposed to tell to what gate is this configuration equivalent to. Okay, so starting with A and B going in OR. So here we'll get A plus B, right? This is OR gate. A and B are the inputs. So the output will be A plus B. Coming to this one, here we have a NAND gate. Okay, this is a NAND gate. So here A and B are inputs again, A and B. So the output will be A into B, the whole complement, right? For NAND gate it is A into B, the whole complement. Okay, now this will go into the AND gate. Okay, so the AND gate basically will take the product of the inputs. Now these are the two inputs, A plus B and A dot B, the whole complement. Okay, these are the inputs. AND gate will take the product of the inputs, right? So this into this. Okay, AND gate basically takes the product of input. If you have A and B going in AND gate, it will multiply A and B. It will take the product. Okay, so now let us simplify this and let us see to what gate it is equivalent to. So we have the output as A plus B. So this is our output, A plus B into A into B, the whole complement. Now we can use De Morgan's law actually, and we can split that up. So basically the law says break the line, change the sign. So just break the line on top and change the sign. So change this to plus. There are only two signs, plus and dot, so you can interchange between them. So De Morgan's law, basically if I had to say it in a lame manner, break the line, so you broke the line between the two and change the sign. Okay, break the line, change the sign. Okay, so now multiply each term. Now open the brackets basically. So this will be a dot a complement, and then a dot b complement. This will be b dot a complement, and finally b dot b complement. Now the first and the last term will be 0. A dot a complement and b dot b complement is 0. Or basically you can also use your sign logic, okay, the logic of your sets, okay. So basically you can replace dot by intersection and plus by union, okay. So that way you can do. So basically dot is replaced by intersections. So what is common between A and not A? Empty set, right? So this is 0. And what is common between B and not B? That is also an empty set. So A dot A complement and B dot B complement is 0. Okay, so finally we have A dot B complement plus A complement dot B. I can write it this way also. So that is our output, and this is the output of nothing but XOR gate. So option B is correct over here. Exclusive OR. Okay, it's a gate wherein if both the inputs are 1, the output will be 0. Okay, it's only 1 when either one of them is 1. Okay, when both are 1, the output will be 0. Anyways, this is the Boolean algebra for XOR gate. So this configuration corresponds to XOR gate. Let's come to this one. This one is also simple. Thermodynamic process is as shown. Okay, it's shown as a PV graph. Okay, this is in meter cube, I shall say. Okay, so let me check that. Yeah, I think it's in meter cubes, so that answer will be in joules. Yep. So you are supposed to tell what will be the work done from D to E to F. Okay, so basically you can basically this is a PV graph, right? So area under the PV graph gives you the work, right? Area under PV graph is the work, right? So you can find the work done under curve D, okay, the area under D, then area under FE, then subtract those areas, right? You want the area, because here if you see the second process is compressing, right? You go to 5 meter cube and then you compress. So work is done on the gas, okay? You want to find out what is the work done by the gas, okay? So of course work done by the gas will be positive and done on the gas is negative, convention, right? So you find this work D to E, F to E, okay? F to E will be negative by nature, okay, and you add those two works and that will give you the answer, okay, or else you can directly find the work done from D, E, F as area under this graph, which will be the area of the triangle. No work is done over here, no change in volume. P delta V, no delta V, no work done. So D, E, F, you can directly find the area of this triangle, half into base into height. Base is 5 minus 2, 3. Height is this, right? Height is 600 minus 300, that is 300. 300s, 900s, 900s half, 450, and in SI units, joules, okay, 450 joules with a positive sign. Yes, clockwise is positive, okay, since the process is clockwise, it is positive. Or you could have found the area under DE curve, okay, if you want to do it that way. Area under DE curve is, it's the area of trapezium, right? So half the sum of the non-parallel sides, sum of parallel sides, which is 600 plus 300, which is 900, okay, into the distance between them, which is 3 again. So 4, I think this will be 2700 by 2, that is 14.5, yeah, so 1, I think 13.5, right? So 1350. So that is the work done by from D to E. Then work done from F to E will be nothing but P into delta V, right? You can simplify it that way, okay, or it's the area of this rectangle, okay. P if you see pressure is constant, so that's why I'm using this 300 into delta V. Change in volume, 5 minus 2, no, it will be 2 minus 5. This is final, right? So I think final minus initial, right? So 2 minus 5 minus 3, that is compression. This will be negative. so minus 900 joules. So when you add this two, okay, the answer that you get is 450, right? So, or you could have directly found out the area of triangle, and since it is clockwise, the answer would be positive. Okay, so that's question 20. So we are done with the multiple choice questions. Now we'll move to something very serious, numerical based question, integer type questions, okay, wherein you are not given any options. Okay, so let's begin with those. 21 and 22 over here, we are stepping into the territory of integer type questions. So question 21, a metal wire of length this, area this, and breaking stress this. A block is attached to one end of this, and you are going to rotate that block in a horizontal circle. Okay, you are supposed to tell what can be the maximum linear velocity that can be attained by that block. Okay, so of course this is the maximum stress. Okay, above that the wire will break. So during this maximum tension, T max, the velocity will be the maximum, because velocity gives rise to your centripetal force. Your centrifugal force, I shall say, is dependent on velocity. Okay, so when the tension is max, velocity will be max, or rather the other way around. When the velocity is max, the tension in the string will be the maximum, and we are given the maximum stress that it can handle. So we'll substitute the maximum stress and find the maximum velocity, or the so maximum velocity that the wire can hold. Okay, above that velocity, the centrifugal force will become too much and the wire will break. Okay, so that is the point of the question. So T is equal to mv square by r, right? So T, here we are given breaking stress. Okay, stress on that word. Okay, stress on that word. So here it's not tension, you can see the unit, it's Newton per meter square. Stress, right, a force per unit area. Okay, so you have to multiply with that with area. Okay, so 5 into 10 to the power 8 into area. Okay, and m, mass of 10 kg. Okay, velocity we are supposed to find what is the maximum velocity. So this is the maximum tension. So for that the velocity will be maximum, right? That is what we are supposed to find. And r is nothing but the length of the wire, right? We are going to rotate it in that horizontal circle. That will be the length of the wire, right? So of course the radius is nothing but the length itself of the wire. Okay, so now let us solve this very wisely. 0.5 into 5 into 10 to the power 8 into 10 to the power minus 4 divided by 10, that will give you v square. So we can write this as 5 into 5, okay, 10 to the power minus 1 minus 1 minus 5 plus 3 and plus 2, I guess, plus 2, okay, which is 10 into 10 I can write, or 100, whatever. So that is v square. So take root on both the sides. 1 5 will survive, and 100 root is 10. So v is nothing but 50 meters per second. So 50 is the correct integer over here. Okay, let's come to this one. Here we have been given the speed of the transverse wave of length this and mass this is this. Okay, the area of the cross section is also given. Young's modulus of the string is also given. You are supposed to find what is the extension. Okay, so this is a string, right? Transverse, we have a wave on a string. Okay, and what is the formula for velocity? Velocity has the formula T into mu. Of course, there should be some tension in the string for the wave to travel, right? When you have the waves on a string, right? So from here you are supposed to find the tension. From tension you can easily find using the formula of Young's modulus. It is FL by A delta L, right? So this is stress by strain. So stress is force by unit area, and strain is change in dimension to original dimension. So from here you can rearrange this, and you can find what you are supposed to find, the extension delta L. Delta L can be easily found as FL by AY. F is nothing but the tension in the string, okay, the force. Here mu is nothing but your mass per unit area. So from here our objective is to find tension. Okay, we are given the speed. Okay, let us square on both the sides. This will give us v square is equal to t nu. T by nu, and from here V square mu is equal to T. So from here our objective is to find tension from this first very statement or the first very sentence. Okay, V square is 60 into 60, mu is mass per unit length, mass of the wire is 10 grams, 10 into 10 to the power minus 3. Okay, place everything in SI. This is tension, bro, and what else? Mass per unit length, right? Mu is mass per unit length. So mass per unit length, 50 into 10 to the power minus 2. Fine, this and this will get cancelled. 5, this is 12, I guess 12, 6 is 72, 72, and one more 0, and okay, 72 with a 0, and here we'll have 10 to the power minus 5, 10 to the power minus 5, that is your tension, or we can say 72 into 10 to the power, it's so less. So I think, okay, this is 10 to the power minus 1, right? So yeah, this will get cancelled. So 72 newtons is the tension in the wire. Okay, so now delta x, or the extension delta L, can be easily found out using this. So F is nothing but your tension force, 12 into length of the wire is 50 centimeters, 50 into 10 to the power minus 2. And what else do we want? Area is 2 millimeter square, 2 into 10 to the power minus 6 in meter square, right? So 10 to the power minus 3, and that's square. And we have Young's modulus. I'll do one thing. Since 12 can cancel this, I'll write it as 12 into 10 to the power 10. Okay, so 12, 6 the, okay, 6 5 the 30. Okay, I can cancel this as well, 3. So that will be 150. Okay, that will be 150, nothing in the denominator, and we have 10 to the power minus 2. Oh, okay, this is 10, right? 10 to the power 10 and 10 to the power minus 6, that is plus 4. Plus 4 goes on top as minus 4 minus 6, 10 to the power minus 6. Okay, this is in meters. Okay, this is our extension in meters. Okay, but our answer is in terms of x into 10 to the power minus 5. Okay, so 15 will convert it into the power of minus 5. So I'll drop 1 0, and that will reduce that. So delta x. So we'll keep our answer in the same format. Okay, so 15 into 10 to the power minus 5. So the value of x over here, not the one that left you, the one over here is 15. Okay, so yeah, 15 into 10 to the power minus 5 meter. Okay, you compare it with this, the value of x, 15. So 15 is the correct integer over here. Over to the next question. 3 and 24 over here. Question 23, we have two radioactive material A and B with decay constants 25 lambda and 16 lambda respectively. If their initial concentration is the same, then the ratio of the nuclei of B to that of A will become E. E is your logarithmic constant, okay, 2.71828. So after time this, the value of A is, okay, so basically you are supposed to take the ratio of number of nuclei B to A and equate it to E. Okay, so first of all, then we'll use the law n is equal to n0 e raised to minus lambda t. So for A we can write concentration of A will be given as n0 e raised to minus, for A it is 25 lambda t. Okay, and for B it is n0, initial concentration is same for both, so n0 same, e raised to minus 16 lambda t. Okay, now take the ratio and be careful, the ratio of the number of nuclei B to that of E. So NB by NA, so NB by NA, so n0 will get cancelled, and this will be minus 16 lambda t on e raised to minus 25 lambda t. Take it on top, that will become plus 25. 25 minus 16, that is 9, e raised to 9 lambda t. Okay, you can clearly see the answer will be 9 over here. Okay, so basically you are supposed to equate this to E, right? The ratio will be E after what time? So here the ratio will become E, so e to the power 1 basically, n lambda t. Okay, 9 lambda t. So the base is the same, so equate the power. 9 lambda t is equal to 1, so t is equal to 1 upon 9 lambda. So if you compare this with this, a is nothing but 9. Okay, yeah, that's your answer. Let's come to this one. From AC, a capacitor of capacitance that is charged using a DC supply. Okay, so we use this battery to charge that capacitor, and now it is connected to an inductor. Battery is removed and it's connected to an inductor of this millihenry, okay, of inductance. So so as to form a LC circuit, the maximum current will be, okay. So basically we can directly answer this by equating their respective energies. Okay, the energy stored in the capacitor is half CV square, okay, and the energy stored in an inductor is half Li square. Okay, so basically you just solve for I, that will be the maximum current, because we are assuming that the entire charge is the entire energy of a capacitor is getting converted into the energy into your inductor. Okay, so that will directly give you the max value for current. So half and half will get cancelled. C is 500 microfarad, 10 to the power minus 6. V square, so 100 square, so 10 to the power 4. Okay, L is 50 millihenry, and I we are supposed to find, so 10 to the power minus 3, that can cancel this. So I'll cancel this first. This is 10 right, and I can cancel 10 to the power minus 3 here. Minus 3 will be left. 10 to the power minus 3 and 10 to the power 4, right. So we can make it 10 to the power 5, ignore this, and I square. This is 100, yes, 100, and that is I square. So I will be 10 amperes. Okay, so the correct answer over here is 10 amperes. 9 and 10, great. Okay, so that's question 24. Let's move to question 25 and 26. Question 25 and 26 over here. In question 25, we are given a modulating signal and we are also given a carrier signal. This is used for amplitude modulation, as you might know. So you are supposed to tell what is the bandwidth of the pass filter. Okay, it's made to pass through a non-linear square law device and all of that. So you are basically supposed to find the bandwidth. Okay, so one important point to remember about bandwidth is that it only depends on the modulating frequency. Okay, it's given as 2 times the modulating frequency. Okay, it's actually bandwidth, you might know it is basically the difference in frequencies, f2 minus f1, right. So f2 is I shall write it as delta f, not to confuse with omega. Okay, so bandwidth is this. So f2 minus f1. f2 is fc plus fm, or fm plus fc, I'll say. Okay, and f1 is fm. Okay, better I'll write this way, fc minus fm. So when you plug in this, so in place of f2, when you put fc plus fm, and in place of f1 you put this, you can see that fc and fc will get cancelled and you'll have 2 times of fm. So that is what your bandwidth depends only on the modulating signal, okay, the frequency of the signal. So you are supposed to compare that with sine omega t, okay, 6.28 into 10 to the power 6 t. Compare this with a sine omega t. So omega, you can see that omega is 6.28 into 10 to the power 6. So divide this by 2 pi. Okay, so that will give you frequency. So this is itself 2 pi. If you see, 2 pi is nothing but 6.28, right? So 2 pi and this will get cancelled. Okay, so 2 pi and that will get cancelled, and will be left with 10 to the power 6. Right, so here the frequency is nothing but 10 to the power 6, 2 into 10 to the power 6. Now 10 to the power 6 is million, right, and megahertz. That is something that you should take away from today's class. Okay, so the integer over here is nothing but 2. okay, and this is megahertz. Megahertz is 10 to the power 6. Let's come to this one. We have a metallic bob. Basically we have a simple pendulum which and that bob has a relative density of 5. Okay, so the density of the bob divided by the density of water, that ratio is 5. And when you swing it in air, the time period is 10 seconds. Now you swing it in water, the time period is 5 root of x. Okay, so you are supposed to find the value of x. उसके बारे में नहीं सोचना है. Okay, so let's find it out. Actually it's you can use the direct formula. Some of you might directly know it. That time period in water is basically when you are given the relative density, you can use that. Okay, so if you want to remember, you can. So this is the time period in water and this is in air. Okay, and rho is the relative density. You can directly actually substitute and find the answer. We'll also do it the hard way. Okay, so time period in air is 10 seconds and we have rho upon rho minus 1. Rho is 5, right? Relative density is 5. So 5 upon 4, right? So 4 we can bring it out as 2. So this is 5. So 5 root 5, right? 5 root 5. So 5 root x, so that value of x is 5. Okay. We'll also do it the hard way. When you immerse the pendulum in water, okay, the forces acting on it. So basically, its apparent weight will change, right? When you immerse something in water, its weight changes, right? Weight in air is different and weight in water is different. Okay. So basically, there will be some upthrust, right, which is V rho g and mg. So this upthrust is somewhat decreasing the weight. Okay, we can say that. Okay, so mg effective, okay, this is the effective gravity or the effective weight, will be equal to this actual weight minus the upthrust, right? So g effective will be, in place of m, mass can be written as density into volume, density of the solid. Okay, rho will use for liquid, okay, which is water, and sigma will use for solid. Okay, so sigma into volume, okay, volume of that sphere. And here mass is again rho into v, and again g. Upthrust is given as volume immersed. Now the entire volume of that bob is immersed, so entire volume, rho, density of the liquid, and into g. Okay, so you can take Vg common over here, sigma minus rho, and we have sigma Vg effective. Okay, so V and V will get cancelled. You can see that what do you get? G effective will be G into, so take sigma to the other side. So sigma by sigma, I am also splitting it up. So sigma by sigma is 1 and rho by sigma. So relative density, what do we mean by that? It is the ratio of the density of the substance to density of water. So this is given as 5. So here if you see, it is 1 by 5, right? It's the reciprocal of that. So G 1 minus 1 by 5, and here it will be 4 by 5, so 4G by 5. So basically the effective gravity changes, right, due to which the time period will change. The time period is 2 pi under root L by G. The length does not change, only changing factor is this gravity. Acceleration due to gravity is itself impacted, we can say. Okay, so here we'll have 2 pi, again it's the same thing. Okay, this ratio is nothing but the value that comes over there. Okay, so yeah, so in place of G effective we have this, right? So we already know that what do we know, that the time period in air, which is 2 pi under root L by G, this value is 10 seconds. Okay, you can now write that as 2 pi under root L by G, and you can keep this separate, right? This is 10 seconds, so 10 into root 5, and root 4 is 2, so again 5 root 5, so the correct answer is root 5 or 5. Okay, the value of x over here is 5. Okay, yeah, that's from question 26. Let's move to the next question. Question 27 and 28, the final few questions, stick with me. So here we are given a nuclear process. Okay, you are supposed to tell the value of Z, which is the atomic number of Z for A4. Okay, after a series of nuclear reactions. Okay, so what will be the atomic number for A1? So for A1, this is after alpha decay. So the atomic number will reduce by 2 and the mass will reduce by 4, right? Then we have a beta minus decay. For beta minus decay, the Z increases by 1. Z increases by 1. Okay, so it will become 71 and the mass remains the same. Okay, then for alpha decay, again, as I said, what will happen? It will decrease by, mass will decrease by 4 and the atomic number will decrease by 2. And finally gamma transition does not change anything. Okay, it is just nucleus going from one excited state to another, but the number of protons or the number of neutrons does not change, hence mass number or your atomic number does not change. Okay, so basically finally for A4, the atomic number you can see over here after the series of nuclear reactions is 69. Okay, yeah, that's correct. So let's get to this one now. 28, the moment of inertia of a thin rod of length L and mass m about an axis passing through a point at distance L by 3 from one end. Okay, so at a distance L by 3 from this end, okay, will be is ml square by a. Okay, so you are supposed to find the value of a. So actually we can do this using parallel axis theorem. Okay, we'll choose one more axis which is parallel to this axis and passing through the center, and of course you'll know the moment of inertia about this axis. I hope you know it, the value. So for, let us call this x. Okay, moment of inertia about this axis as x. Okay, so moment of inertia about that axis will be moment of inertia about the axis passing through the center of mass plus mass of the entire body into distance between the two parallel axes, right? This is the parallel axis theorem. Now moment of inertia about the axis as shown, which is passing through the center of mass, will be ml square by 2l. I hope you know that. So moment of inertia for rod rotating from one end is ml square by 3, and rotating from the middle, from the center of mass, is ml square by 2l. Okay, now here we have m, and what will be d? D will be basically L by 2 minus L by 3. Okay, so L by 2 minus L by 3, I think it's L by 6, right? L by 2 minus L by 3. Okay, that is 6, 3L minus 2L. I think, yeah, L by 6. So ml square by 36. Okay, so basically squaring it. So this distance is nothing but L by 6. Okay, so ml square by 36, we can multiply this by 3. So 3 ml square plus 1 4 ml square by 36. So basically solving it, ml square by 9. I think that's correct. So 9 is the correct choice over here. The value of A over here is 9, ml square by 9. So 9 is the integer that we were looking for. So over to the last two questions for the day. One question from that will be your homework question. Okay, so let's move to them. The final two questions for the day. Okay, so question 29, here we have a tube. Okay, it's of length some 50 centimeters, and we are going to rotate it with some angular velocity omega. It is filled with an incompressible liquid of mass this. Okay, now when you are rotating it, of course the fluid will be pushed to the other end, right? And this will put some force on the other end, right? So you are supposed to find that force. That force is given as F. Okay, and your angular velocity which is there, it is expressed in terms of F. Okay, x times of root F. Okay, you are supposed to find the value of that x. Okay, so our approach is very simple. We'll be using the process of integration. We'll take a small mass dm of length dx at a distance x. Okay, and we'll find the force due to this, and then we'll integrate it from 0 to L, okay, over the entire length. So that will give us our force in terms of omega, and then we can substitute and find the value of this x, okay. So we are considering a small element d of mass dm. Now dm can be expressed as m by L into dx, right, by uniform relations, right. So basically if the mass of the entire tube is m and it corresponds to length L, so length of the tube is L, for that the mass is m. So for element of length dx, what is the mass? Dm, right. So dm can be easily seen as m by L into dx, right, or I can write it this way, right. So dm will be m by L into dx, right, m by L into dx, okay. So that is dm. Now force due to df, we can say it is dm into a, right. Now a is the acceleration, this is mass, this is acceleration. Acceleration, you can write it in terms of omega square r, right, in terms of angular velocity I'm saying omega square r, okay. So here it will be omega square x, right, it is at a distance x, okay. So now what can we do? We can substitute that and integrate that force, okay. So F will be nothing but integration of df from 0 to L, okay. You want it over the entire length, so 0 to L, dm is m by L into dx, and we have this acceleration as omega square x. Now remove everything out which is common. Now this x is different from this x, okay. This is x, this x represents a value, this x is our distance, okay, this distance, okay, at which we chose our unit element, okay, it's a variable, okay, this is a constant value, okay. So now coming back, your omega square also comes out and we are left with x dx, right. So that will be half m omega square by L, and x, integration of x is x square by 2, yeah, that is why I took the half out. So x square by 2 and then substitute the limit, so L square, right, L square minus 0, okay. So this L can get cancelled, so we are left with half m L omega square. This is nothing but the force. Now we can substitute in place of omega r this. We are given that the uniform angular velocity is this, so directly substitute it, okay. So I'll do it over here. F is half m L omega, in place of omega square we can put this x f, right, x square f, okay. That f and f can get cancelled, so 2 by ml, 2 by ml will give us x square. Now let us substitute all the values. So 2 divided by m, m is the mass of the fluid, and 250 into 10 to the power minus 3, since it is in grams. L is the length, 50 centimeters, 50 into 10 to the power minus 2, okay, and that is x square, okay. Let us solve that. So x square will be equal to, let us take the powers of 10 on top, so that is 1000, right, and this is 100 upon 250 into 50, so 50 2s are 100, and this can get cancelled, 25 4s are, okay. So this is 4 and 2 2s are is also 4, 4 4s are 16, and basically square root of that is 4 again, okay. So x, the value of x is nothing but 4, not 9, 4, okay. So that's about question 29. Question 30 is your homework question. Do try it and do let me know the answers in the comment section. It asks you for the RMS velocity of hydrogen molecule at what temperature is equal to the RMS value of oxygen at 47 degrees Celsius, okay. So do tell me the value in Kelvin, okay. So this is the value of RMS velocity of hydrogen at what Kelvin, at what degree Kelvin, not degree Kelvin, what Kelvin is equal to the RMS velocity of oxygen at 47 degrees Celsius. Okay. Just one more thing before we go. If you want the chemistry and the math section of this paper, you can refer to 29 July evening shift paper 2022. Okay, that paper is pretty much based on similar lines. It's very much close to this paper, so you can refer the chemistry and the math section of that paper. Okay, so if you want the chemistry and the math side too. Okay, so that's all from me today. I hope you enjoyed it. I'll see you soon in the next video. Till then, keep enjoying physics.